So in this video, I'm going to start talking about stereochemistry, but more specifically chirality in carbons. And so first, let's get some background about it. So what does chiral mean? Well, chiral means that it's essentially handed. And so hands are mirror images. And so when we talk about chiral things, we're going to talk about chiral carbons. So a chiral carbon has to have, a chiral carbon is an sp3 hybridized carbon with 4 substituents. And so if you have 4 different substituents, the carbon is said to be chiral. So 4 different substituents. If you have 2 hydrogens on there, or 2 of the same things, then it is not chiral. So often you can designate a chiral center by using an asterisk. So this designates chiral centers. And so let's pick out a molecule. I'm just going to draw one out. And so here, let's try and identify the chiral centers, if there are any. And so first, let's start off with this carbon right here. And so it has 3 hydrogens bonded to it. And remember, we said it has to have 4 different substituents to be called chiral. So this carbon is not chiral. And so let's go to the next one. This has a bromine. So this carbon right there, it has a bromine coming off of it, a CH3 coming off of it, a hydrogen, and another whole thing. So this would be designated as chiral by using the asterisk. And then the next one as well, this carbon would also be chiral because it has 4 different substituents binding to it. And then finally, this carbon is not chiral, just like the first one. So here you have 2 chiral carbons. So when we talk about mirror images, for example, your hand here, let's draw your hand, your 2 hands. So your thumb, index finger. So that's one hand, and then pretend this is a mirror. The other hand will be like this. And so they're mirror images of each other. And so a term for mirror images is enantiomers when it comes to organic chemistry. Enantiomers. And these are non-superimposable mirror images. And so what that means is, if you tried to stack your hands, this hand on top of this hand, or vice versa, without rotating it, you could not do that. And so a great way to figure out if something is a mirror image of each other is to assign R and S configurations. But I'll talk about that in the next video. But first, let's do some more practice with identifying chirality in carbons. And so let me draw out a couple structures. So let's compare these two molecules. And so a good way to help you see this is to get a model kit to build the molecules. But if you look at this molecule, you can tell that these two molecules are not the same. And they're actually enantiomers, which means mirror images. And so with more practice and building more model kits, you could probably see it better. But for this video, I just wanted to summarize and introduce the concept of chirality. And in the next video, I'm going to talk about determining chiral centers, so R and S configuration. You'll learn about that. And so I hope you found this video helpful. If you did, please like it and share it with your friends.